Attention is the key to unlocking transformer model's power. So today we will understand self-attention and cross-attention with relatable real-life examples. So let's start with self-attention mechanism first. Now what is self-attention? So basically self-attention is a technique that allows models to focus on important parts of the input sequence, which enable them to better understand the context and relationship between the elements in the input. So to understand this better, imagine you are a gardener and you are tasked with creating a planting plan for your garden. Now your garden consists of various plants and you need to ensure that the plants are arranged in a way that maximizes growth and yield. Self-attention can be thought of as a mechanism that helps you achieve this by allowing you to focus on different parts of your garden simultaneously. For example, when arranging the plants, you might start by focusing on the area where you want to plant tall, fast-growing vegetables like corn and consider how much space they'll need. While doing this, you are also able to consider the relations between the tall vegetables and other plants in the garden, like shorter, slower growing vegetables like lettuce or decorative plants like flowers. So in essence, self-attention allows you to effortlessly and efficiently arrange your garden by dynamically focusing on different parts of the garden, while considering the relations between those parts to create an optimal planting plan. So in the context of natural language processing, self-attention is used by transformer-based models to learn the relations between the words in a sentence and identify important contextual information, which is crucial for tasks like machine translation, text classification, and question answering. So to understand this better, let's code a self-attention in Python. So in this example, we'll demonstrate the mechanism for single query key and value vector. But you can easily scale that for the multiple inputs. And we'll use the same formula where we will have this matmul, we'll do the scaling, and finally we will do the softmax multiplication. So this is the code. In this code, we have defined a function called self-attention that implements the self-attention mechanism, which is a fundamental component of transformer-based models like BERT. Now this function takes four inputs: query vector, key matrix, the values, and the dimensions of the key. Now this function first compute the attention score by taking the dot product of query and transposed keys, then dividing the result by square root of the dimensions of the keys. So this is known as scaled dot product attention. Next, the attention scores are normalized using a softmax function along the first dimension, which ensures that the attention weights sum up to the 1, reflecting the relative importance of each key in the context of the query. Now this context vector is computed by applying the attention weights to the value matrix via matrix multiplication. Now this weighted sum of the values is the output of self-attention mechanism and represents the context vector, which is a modified version of original query vectors incorporating information from the keys and values. And this function returns the context vector. So after defining this function, code creates example input tensors and demonstrates how to use the self-attention function. It prints the shape and the content of the context vector as well as the input tensors and the attention scores. So this example helps illustrate how the self-attention mechanism works for a single query key and value. So in practice, we often work with multiple queries, keys and values, and the process would be similar, but the operation would be performed in a batch manner. So these are the results when we will implement this Python code in Google Colab. Next comes the cross attention mechanism. Now this cross attention is a mechanism used in transformer based models that enables them to attend to information from different layers or subcomponents within the model which allow the model to capture complex relations between the different parts of the input sequence. So imagine you are a tour guide and you're tasked with creating a personalized itinerary for a day trip. So to do this effectively, you need to understand the relations between the different points of interest, example, museum, landmarks and restaurants, and the context provided by the overall trip theme and the preference of your travelers. So this cross attention allows you to effortlessly and efficiently create the itinerary by dynamically focusing on different parts of the trip. Example, morning activities and afternoon activities, and accessing contextual information from other parts of the trip. Example, the overall theme and the preference of your travelers. So this helps you design a well-rounded and enjoyable itinerary that takes into account the broader context and the interest of your travelers. So in the context of natural language processing, cross attention is used by transformer-based models to enable them to attend to information from different layers or subcomponents within the model, which allows the model to capture complex relations between different parts of the input, which is crucial for tasks like machine translation, text classification, and question answering. So let's understand it better using a Python code. So in this code, we have defined a function called cross attention that performs a single round of attention calculation in transformer based model. Now this function takes four input arguments: query, keys, values, and the dimensions. Now query is a one-dimensional vector of shape 1 and dimensions representing the query vector for attention mechanism. Keys are a two-dimensional matrix representing the key vectors. Values is also two-dimensional matrix, and this dimension is an integer representing the dimensions of the key. Now this function first computes the dot product between the query and the transposed keys, and then scales the score by dividing them with the square root. So this scaling is a common practice in transformer-based models. Next, the function computes the attention weight using the softmax function. So to avoid numerical issues, the function first subtracts the maximum values from each element of the attention scores arrays, effectively shifting the values to be centered around 0. Then it applies a softmax function using a custom implementation like this, exponential scores and all, instead of using np.softmax. So this custom implementation is used to avoid numerical issues that may arise when computing the softmax of large input values. And finally, the function computes the context vector by applying the attention weights to the values using a dot product and returns the context vector. Now the code then creates example input tensors, computes the context vector using cross attention mechanism, and print the results and the input tensors. So this example demonstrates the calculation of attention for a single query key and value input. In practice, we often work with multiple queries, keys and values, but the process would be similar and the operations would be performed in a batch manner. So let's understand what's the basic difference between this self-attention and cross-attention mechanism. So first difference is in input, as self-attention operates on a single sequence, whereas cross-attention operates on two separate sequences. So in self-attention, the input sequence attends to itself and learns to weight different parts of its own sequence. In cross-attention, two separate sequences, example source and target sequence in machine translation, are fed into mechanism, allowing the model to learn relations between the parts of both sequences. Second is the focus. Now this self-attention focus on understanding the internal relations within a single sequence, whereas cross-attention focuses on learning relation between two separate sequences. Self-attention is useful for tasks like language modeling, where the model needs to learn the relation between the words within a sentence, whereas cross-attention is essential for tasks like machine translation, where the model needs to align words across two different languages. Next comes attention queries. So in self-attention, the same set of queries is used to compute the attention weights for all the positions in the sequences, whereas in cross-attention, separate queries are created for source and target sequences. Now, self-attention queries are typically initialized randomly and learned during training. And in the cross attention, queries for the source and target sequences are typically initialized differently to encourage the model to focus on different aspects of the input. And the next difference is in training. So self-attention is typically trained using a single sequence, whereas cross-attention is trained using two separate sequences. The self-attention is often used as a building block within a transformer model which processes a single sequence, whereas cross-attention is a key component in many transformer-based models that perform tasks involving multiple sequences such as machine translation, summarization, and question answering. Thank you.